All right, this is exam 3 for physics 201, multiple choice first. When a car travels around a curve, what force provides the centripetal force? That would be the frictional force between the tires and the road. That's the actual force that causes the car to go in a circular path. Liza sits on the outer rim, Chad sits midway. Uh, it makes a certain 1 revolution every 2 seconds. The angular velocity here is the same as it is here, so his is the same. That's C. How many revolutions in 600 degrees? Well, you just say 600 degrees times 1 revolution over 360, and that's equal to 1.7. 1.7, so that's C. An object at rest begins to rotate with constant angular acceleration. If this object rotates to an angle theta, what angle does it rotate in time 2t? In time 2t? Well, I know that theta is equal to 1/2 alpha t squared. So if it rotates through angle theta in t, then in 2t, it's going to rotate through angle 4 theta. So that is, what is that, C here? No, that's E. Looks like E. E. All right, buckets are spinning horizontally on frictionless bearings. Suddenly it starts raining. Which of these statements is true? This is very similar. Well, we had this in a concept test question. The moments of inertia will increase because the mass is increasing. So the momentum stays the same, so they slow down. Let's see, so that is B. B for number 5. Which of these is the basic SI units for torque? Well, torque is a Newton meter, so that is kilogram meters per second squared times meters, so that's kilogram meter squared per second squared. That's B. You want a seesaw with your 3-year-old nephew. He sits on the seat of the seesaw. Where should you sit? You should sit closer to the pivot point. So if your little nephew is here, here's your pivot point. You need to sit there. So it's closer to the pivot point. That's C. Two spheres have the same mass. One is made of aluminum. The other is made of gold. Both are solid. So that means that the radius of the gold sphere is much smaller. So this is the gold, and this is the aluminum. The aluminum is a lot bigger. So the aluminum has the same mass, but it's distributed over a larger radius. So that means that the aluminum sphere has the larger moment of inertia. So that's A. Bernoulli's equation is based on which of these laws? Bernoulli's equation is based on the conservation of energy, in particular the conservation of energy per unit volume. Consider this section of pipe that narrows as it goes from left to right. An ideal fluid flows through the pipe. Where is the pressure highest? The pressure is highest where the velocity is lowest, and it's wider down here, so the velocity is lowest there. So that's A. The presence of dark matter was inferred by Vera Rubin by observing which of these? These are just gobbledygook. Uh, she didn't observe gamma rays. She did the rotation rates of galaxies. Remember, she also measured the light from the galaxies and compared those two masses, the light mass and the dynamical mass. Consider this manometer, which statement best describes the relationship between P and P naught. Okay, well, P is less than P naught because we have this column here, so this pressure has to be less. P is less than P naught, that's C. 12 is C. Consider the plots of displacement versus time for the object in simple harmonic motion. How do their periods compare? Okay, well, the period of the first one, which is the time between successive peaks, is larger than the period of the second one. So this time is the period, whereas here, this time is the period. So the period of object A is larger than the period of object B. Consider this graphical representation. Its position and velocity are what? Well, the position is positive, and the velocity, which is the slope, is negative. So position is positive and velocity is negative. That's D. The frequency, if the frequency of periodic motion increases, how is the period affected? Well, the period is 1 over the frequency. So if the frequency goes up, that means the period goes down. Okay, these are the free response. This first one was worth 15 points. I was very lenient. If you had some inkling of what was going on, then I generally gave you uh, most of the credit. First, we have to define a differential. It has a width dx, and we're going to integrate over that differential, and we're going to go from minus L over 2 to L over 2. So minus L over 2 to L over 2, where the length of the bar is L. And so I define the mass of that differential. It's equal to the mass over the length. That's the total mass over the total length, big L, times dx. This m over L is just the linear mass density. Now I, by definition, is equal to the integral of x squared dm. All right, that's just the definition for moment of inertia. And I have this definition for dm, or this designation for dm. So it's the integral of x squared m over L dx. I can take the m over L out because it doesn't change with x, and it's just the integral of x squared dx, which is x cubed over 3, over my limits of integration, which are minus L over 2 to L over 2. Then I want to apply my limits of integration. I'll take the 3 out up here, so I get m over 3L times L cubed over 8 minus negative L cubed over 8. So this becomes a positive, and this simplifies to 1/12 mL squared. It's different from this. We called it L was B, so it's just a different designation that B is the same as L, just the length of the bar. I was fairly lenient. If you had most of that, I gave you all the credit or most of the credit. All right, solid disc has a mass of 120 kilograms. Initially at rest, small wheel turns the disc by applying a force is given. Force is applied at a coordinate of 3, 4 meters as shown in this figure. What is the net torque? All right, so to find the net torque, A, torque is equal to R cross F. My moment arm is 3I plus 4J, that's given here. 3I plus 4J. And then my force is just given outright, minus 7.2I plus 9.6J. All right, that's cross of those two. However you want to do the cross product's fine. I'll do FOIL. I'm just going to leave out the I cross I and J cross J terms because those are equal to 0. And I get 28.8 I cross J. 28.8 is 3 times what? 9.6. What's that? Yeah, 3 times 9.6 minus 28.8 J cross I. I cross J is equal to K, and J cross I is equal to negative K. So those can add up to give me 57.6 K. So that's the torque in vector notation. What is the angular acceleration? So in part B, I need to know the angular acceleration. Alpha, it's equal to the torque over the moment of inertia. The torque is 57.6 Newton meters. And then the moment of inertia, I have to determine, it's a disk, so the moment of inertia is 1/2 mr squared. That's 1/2 of 120 kilograms times the radius squared, 5 meters. And that's equal to 0.0384 radians per second squared. Well, let's see. So I counted this part A as 6 points, and I counted part B. I counted this part 6. I counted this part, just finding the moment of inertia, as 4 points, and then this part as 4 points as well. In part C, I want to know what is the angular velocity of the large wheel after 12 seconds. Omega is equal to omega naught plus alpha t. I already have alpha, I have t, omega naught, since it's at rest, is equal to 0. So this is just equal to alpha, which is 0.0384 times 12 seconds, which gives me 0.46 radians per second. That part of the problem was worth 4 points. And then in part D, I want to know the velocity of the smaller wheel. All right, so the smaller wheel has the same angular velocity as the bigger wheel, because it's actually driving the bigger wheel, it has the same angular velocity. So I just want to know what is the linear velocity. So that's just equal to omega times r, which is 0.46, times the radius of the smaller wheel. That radius is given right here, is 0.8 meters. And that gives me the linear velocity of the smaller wheel, which is 0.37 meters per second. And that was worth 2 points. Next page. Okay, a garage and a lift has a 53 centimeter diameter piston supporting the load. Compressed air with a maximum pressure of 200 kilopascals is applied to a small piston at the other end of the hydraulic system. What is the maximum mass the lift can support? So I know that the pressures have to be constant, and on one end, like on this lift, I have this lift, and the pressure here has to equal the pressure here, and the pressure on the left-hand side is 200 kilopascals. That's 200 times 10 to the third pascals, and then that has to equal the pressure over here, and the pressure over here is force over area. So we have 200 10 to the third is equal to the force over the area, which is pi times r squared, 0.53 meters, divided by 2 squared. If I solve for the force, then that's the weight of the object that it can lift, is 44,000 newtons, but I was asking for mass, so mass is force over g. It's 44,000 over 9.8, which is 4,500 kilograms. This is very similar. I think it was actually identical to a homework problem. 4,500 kilograms. This problem was worth 15 points. 10 points. This was worth 8, and this part was worth 2 points. What is the position function for a particle that has a period of 2.3 seconds angular frequency and a maximum velocity occurring at t equal 1.2 seconds? All right, I didn't include this at all in calculating doing your grades because I made a mistake on this. I was supposed to come back and change this. So you're still responsible for the final, but let me just correct this. This part needs to go away, the angular frequency of 3.4 seconds, and the maximum velocity is given for the problem, and it's equal to 3 meters per second. All right, and then I can work it in this way. So I know that my period is equal to 2.3 seconds. That means that my frequency is 1 over 2.3, which is 0.43 hertz. That's my frequency. And then I want to know what is the position function. That is x of t is equal to a cosine omega t plus phi. So I have, I need to know a, I need to know omega, and I need to know phi. Well, I can find omega first. It's equal to 2 pi times the frequency. 2 pi times the frequency, which is 2.7. And then also need to know a. Well, I know that V max is equal to a times omega. And since I know V max and I know omega, I can find a. So a is equal to V max over omega. That's 3 meters per second over 2.7. So a is 1.1 meters. So that's a. I have omega, I have a, and now I need to find phi. Well, I know that the maximum velocity occurs at t equal 1.2 seconds. And for the maximum velocity to occur, omega t plus phi has to equal 3 pi over 2. Remember, the velocity as a function of time is negative a omega sine omega t plus phi. And in order for this to be maximum, this sine of omega t term plus phi has to equal -1. That means that this has to equal 3 pi over 2 because the sine of 3 pi over 2 is -1. And then that gives me my maximum velocity. So that's where this 3 pi over 2 comes in. So I just plug in my numbers here. I have 2.7 times my time, which is 1.2 seconds, plus phi equals 3 pi over 2. And then solving for phi gives me 1.47. All right, so those are my three terms. I just plug them in here. I have 1.1 cosine of 2.7t plus 1.47. That's my position function. And then I also wanted to know what is the acceleration. Well, the acceleration as a function of t is minus a omega squared cosine omega t plus phi. And I just want to know what is the acceleration at t equal 3.5 seconds. So I just plug in these numbers. Minus 1.1, 2.7 squared, cosine of 2.7, that's omega, times 3.5 plus 1.47. If I just do that in my calculator, I find that A is equal to minus 7.9 meters per second squared. That's my acceleration at 3.5 seconds. The point distribution, it didn't apply to you, but I had 4 points for each of these for A, omega, and phi. So that's 12, and then I had 3 points for the acceleration. Again, I did not count this on your test. A number of you tried to get it right, but you didn't have enough information to solve the problem. And a number of you actually sort of knew what was going on, but again, it was not solvable the way that it's written. In fact, there were some contradictions because the period is 2.3 seconds, but that doesn't give you an angular frequency of what was written of 3.4. It instead gives you an angular frequency of 2.7. So I apologize for that. I gave everybody the full 15 points for it. All right, a boat floats in water. 2/3 of the volume is submerged in the water. The volume is 3 meters cubed. What is the mass of the boat? So I have this boat. 2/3 of the volume is submerged, and I want to know the mass of the boat. I know there are two forces, the buoyant force and the weight of the boat, and the buoyant force is equal to the weight of the boat. The buoyant force is given as the density of the fluid times the volume of the object, or in this case, it's actually 2/3 the volume of the object because that's the amount that's submerged, times g, and then that's equal to m times g. My g's cancel out. Let's see, I'm looking for the mass of the boat, all right, which is this term right here, and I know everything. Well, I don't know everything, but I know everything for this problem. The density of the fluid is 1,000. That's for water. It was kilograms per meter cubed, times the volume of the object, which is 3 cubic meters. And then that's equal to the mass of the boat. So that's 2,000 kilograms. And that was a 10-point problem. You got it, you didn't really. There's the multiple choice answers.